Hello everyone, I'm Katz.
I'm Jacob Burnley.
I'm Benji Gourdji.
And I'm Chris Wu, and today we are going to be talking to you about our more fatigue assembly for ME321. This project was primarily motivated by a desire to learn more about the fatigue life of 3D printed PLA plastic. As we know, if we take some material, which in the case of this project was a 3D printed PLA shaft, and cyclically load it, even if it's loaded under conditions that don't cause yielding, it will most likely fail after a large number of cycles. To design around fatigue failure, it would be useful to develop a model that predicts the number of cycles until fatigue failure for a given set of shaft parameters and loading conditions. Creating a model, however, would require designing an experiment and collecting a large number of data.
And now I'm going to give a general overview of the assembly that we built. As you can see right here, this is the assembly we built to test the fatigue properties of our shaft. Most of the structural components are 3D printed, which includes the pillow blocks, bearings, motor mount, and the shaft itself. To measure the speed of the shaft, we have two encoder wheels, one here and one here, and two optocouplers. There are holes in these encoder wheels that and if we count the number of holes that pass during a given amount of time, we can figure out how fast the shaft is spinning. Additionally, we have some other components over here that are necessary for the functioning of our apparatus, which includes an SD card reader that allows us to store the data from our experiment, along with a relay right here, which allows us to turn the motor on and off if needed, and an LCD screen right here, which allows us to display relevant information such as how fast the shaft is currently spinning.
An integral part of this experiment is recording data. By writing data to a CSV file on a micro SD card over the ESP's SPI connection, we can have an individual data set for every single test. Then, since the ESP32 is Wi-Fi enabled, we can upload the CSV to a cloud storage bucket hosted by Google's Firebase service. Once it's there, it can be accessed anywhere on our website and downloaded for further analysis.
Here are some of the results we got from running a few shafts on the apparatus. Our group specifically tested a few different combinations of perimeter and infill percentages, and as you can see, the data is kind of all over the place. In fact, we even had two completely identical shafts that broke at significantly different times. If we were going to draw any actual conclusions from this data, we would have to do a significant amount of additional testing.
Overall, from this project, our group learned a lot. After going through the whole design process, we learned two major lessons. The first one is to always have a backup plan. The reason we learned this is because one of our fatigue tests, we had an issue where one of the encoder wheels seized on the shaft, and we had to discard a shaft, bearings, and the encoder wheel. We had also printed other additional parts before this happened, so it ended up being okay, but having a backup plan would have made that much more streamlined. The second lesson we learned is how important communication is. With such a chaotic project, with deadlines shifting and objectives shifting all the time, it's so important to have the whole group communicating and communicating often.
If we were going to conduct this experiment again in the future, there are a few things that we could do in order to make the experiment run more smoothly. The first of these is to print our parts in some more wear-resistant materials. Some of our parts, specifically our bearings, wore down quite a bit faster than we originally anticipated. So had we printed these parts in something more wear-resistant, such as PETG, this probably would have helped mitigate the issue. Additionally, we noticed that when running our motors for a prolonged period of time, they got, to say the least, uncomfortably hot. To remedy this, maybe in the future someone could machine an aluminum heatsink for the motors, or if you were feeling very fancy, maybe you could make a water block system or something of that sort.
Thank you for watching our video about the design process for our fatigue testing apparatus. And if you're an ME321 student, hope you learned something from this, and good luck, and that's it.